Good morning, dear students. Today we are going to study exercise 1.4 deals with the decimal expansions of chapter 1 real number from 10th of Punjab School Education Board. In this exercise, we'll try to understand what are terminating and what are non-terminating decimals. Let us try to understand this concept with the help of examples. Question number 1. We have taken here 13 by 2, 13 by 5 and 13 by 6. First of all, we are taking those numbers in which numerator is a prime number and the denominator is also a prime number, but the first prime number in denominator is 2. Let us divide this. We'll get 6.5. Let us solve this. We'll get 2.6. Now we have divided 13 by 2, we get 5.6, which is terminating decimal. If the decimal ends at some place, that is called terminating decimal. And 13 by 5 is also a terminating decimal because it ends at 6. Now let us check 13 by 6. Divide this. And we'll get the repetition of 6 if we divide 13 by 6. 1 0 decimal 61640 6 6 36 again 40, and we'll get 66666 again and again because we are leaving 4 as remainder here in each term. So this is the repetition of 6. We can write it as 2.16 bar. Bar represents the repetition. Now let us analyze this. 13 by 6 equals to 13 divided by 2 multiply 3. So it's clear here that if any prime number which is divisible by 2 may ends after decimal, and if it is also divisible by 5, then it becomes terminating. But if there is any other prime number in the denominator other than 2 or 5, that means we are having here 3, so this will become non-terminating decimal number. These are called terminating, and this is non-terminating. In above questions, we have taken only prime numbers in the numerator. Let us take a non-prime number, that is composite number, in the numerator. So first of all, we'll check that if there is any common prime number which is dividing numerator and denominator. There is not any common prime number which divides 33 and 125. So if we divide 33 by 125, after division we got 0 decimal 2, 6 and 4, which is again a terminating decimal. Now let us conclude what we got here. 33 divisible by, we'll take the prime factors of 1 to 5. We got so the prime factors are 5 multiply 5 multiply 5. This will become 33 by 5 cube. So we conclude here that if there is any prime or composite number in the numerator, but if there is either 2 or 5 in the denominator with any power, that will make the fraction a terminating decimal. But if there is any other prime number except 2 and 5, or we can say with 2 or 5, if there is any other prime number in the denominator, then the fraction will become non-terminating, repeating or non-repeating? Now let us check. Without solving this sum, we'll take prime factors of 390. So we are having here 1, 2, 7 and 3 multiply 5 multiply 2 multiply 13. So we can check easily here. This number is not divisible by 3, neither by 5, nor by 2, nor by 13. So there are 2 and 5 as denominator, but 3 and 13 are also there. They will convert this decimal in non-terminating. Non-terminating. So let us check another example. We are here. So we can check here the number. This is divisible by 11. This is again divisible by 2. We got 1 by 50. Now we'll take the prime factors of 50. As we can see here, the prime factors are 2 multiply 5 raised to power 2. So we can easily judge here that this term would be a terminating decimal, because there are only two prime factors in the denominator, that are 2 and 5. So we conclude here that if we are having the prime factors in the denominator as 2 or 5 or both, then the rational number will become terminating decimal, or otherwise if there is any other prime factor of the denominator, that becomes non-terminating decimal. Now let us solve another problem of this concept. Write the terminating decimal form. We are to convert this number in decimal form. So we'll have to take the prime factors of the denominator. So we get 5 multiply 5 multiply 5 multiply 5 multiply 5 times. So 13 divided by 5 raised to power 5. So to make it a terminating decimal, we'll multiply the numerator and denominator by 2 raised to power 5. That will make this denominator as 10 raised to power 5, multiple of 10. So in decimal form we got 0 decimal 0 0. This is in terminating decimal form. Another example, 17 by 8. We'll take the prime factors of denominator. We get 17 by 2 multiply 2 multiply 2, that is 17 by 2 power 3. So we can say it's a terminating decimal number. So to make it in decimal form, we'll multiply numerator and denominator by 2 raised to power 5 raised to power 3, so that the denominator will become in the form of 10. After multiplying, we'll get this divided by, so the result will be 2125. In this question, no need to solve this till the minimum digit, we'll divide this number only by 11. We'll get 11 by 100 because the denominator has become a multiple of 10. So we can directly write in decimal form. So this is our terminating decimal. We are given here a question 443 decimal 1 2 3 4 5 6 7 8 9 and 10. We have to check whether this is terminating or non-terminating. As we have studied, if the decimal ends at some digit, that means that is a terminating decimal. So we can say this number is having limited decimal places. So it's a decimal number. It's a terminating decimal number. So we can write it in the form of P by Q, where Q will not equal to 0. But if the decimal is terminating, we know that the denominator will have factors or prime factors only 2 or 5 or both 2 or 5. We can write it as Q can be 2 or 5 or 2 and 5 both as prime factors of any power. So we can write this number in the form of P by Q. Now in this second example, we are given here one decimal 120 1200 12000 and so on. This represents this is non-terminating decimal number because the digits are repeating but not in same sequence. There is 1 0, there are 2 zeros, there are 3 zeros. So the term is not repeating properly. So this term will not be a terminating decimal. So this number will be a non-terminating decimal. So we cannot convert the above question in rational form. We cannot convert this in the form of P by Q. Let us take another example 4 3 decimal 1 2 3 4 5 6 7 8 and 9, but there's a difference between these two questions. There's a bar on this number, which means this term 1 2 3 4 5 6 7 8 9 is repeating again and again. If the number is having a repetition after decimal, that means that number could end at some digit. That means we can represent that number in rational form because the number is non-terminating but repeating, or we can say recurring, repeating again and again. Therefore we can represent the above number in the form of P by Q, where Q will not equal to 0, or as we have studied, the prime factors of P would be 2 or 5 or 2 and 5 both in any power. So we can represent the number which is non-terminating but repeating in the form of p by q, that is in the form of a rational number. So with this we have completed our exercise 1.4 of real number decimal expansions. Dear students, if you find any problem in solving any number, any sum, you can contact me. Thank you.